This is section 2, using resources to automate systems. In this section, we will explore the main manifest. We'll look at applying a resource to a node, understanding the node catalog. We'll look at some useful resource types. We'll talk about how to implement resource order and dependencies. We'll talk about refreshing Puppet resources, exactly what that means. And we'll look a little bit further at environments. Exploring the main manifest. In this video, we'll talk about the Puppet manifests directory. We'll talk about the files in that directory and their format and how they're organized. And we'll do a brief demo of installing a package using a Puppet manifest file. So the manifests directory is one of the main directories inside our environment. And the term manifest in Puppet really just means a file that contains Puppet code. So when we talk about a Puppet environment, we have a number of different directories. You see manifests, modules, data, and here a configuration file. We'll talk about each of those in turn, but we want to focus first on manifests. So inside the manifests directory, that's really the top level or the main place where Puppet starts when it's running the environment for a particular node to apply configuration to a particular node. Now, the files in that directory are in a Puppet code format. They have a .pp extension, so they're written in the Puppet language. Now, the syntax for that language is similar to Ruby, but Puppet has its own subset that is more restrictive, some ways in which it's different from Ruby, and in general, it doesn't include all of the features that Ruby includes. Puppet includes a parser that actually parses Puppet files that's different from just like a typical Ruby compiler. And then finally, the key thing to note, the most important thing as we start to look at manifest files, is to remember that this is not like code that we're executing. It's not like a script that we're running. What we're doing is we're expressing the desired system state. So we tell Puppet what we want for system state, and then it's Puppet's job to examine the current system, see if any changes need to be made, and then only make the required changes to get the system to the necessary state. Let's take a look at what a Puppet manifest file looks like. So you'll notice here that we have a Puppet production environment. So if you remember from our discussion of environments in the last section, we talked about how they are separate sets of Puppet code that we can use to organize different systems. So in this case, we're using production, which is the default. You'll see we have a manifests directory, and under that I've created a file called site.pp. Now, that is a convention for the name of the file in that directory. You may also see default.pp. The name doesn't really matter. What Puppet will do is it will read all the files in this directory and all the files in all the subdirectories. Anything under manifests is going to get read. It's going to get pulled in. It'll be part of that main manifest that's used to configure the systems on our network. So in this case, you see I have some Puppet code. Now the details of exactly what this does, we'll need to talk about classes and include and those kinds of things. But you can see a little bit of the syntax. You'll notice that we open with an opening curly brace. We always use a closed curly brace. You'll notice that we have the colon here in order to define a resource. And then we use this little arrow to indicate the value of a parameter. So, in some ways this does look like Ruby, but you can see that there are some important differences. So in order to kind of illustrate the simplest possible manifest, I've created a separate example file, and this just contains one resource. So again, keeping with what I said a moment ago, it's important to note we're not telling Puppet to run the package installer and install this package. We're telling Puppet to ensure that this package is installed. If the package is already installed, if it's already in the correct state, then Puppet is not going to do anything. So again, what we're doing here is we're not writing a script, we're expressing the desired system state, and then it's Puppet's job to put the system into that state. So you can see a manifest file can be very simple. It can just contain, some piece of desired system state. In this case, we're telling Puppet that we would like the Vim enhanced package to be installed. We want Puppet to make sure that that's true. So in order to try this out, we're going to use Puppet in its apply mode. So that's very simple. We just run Puppet apply, and then we give it the name of the file that we want it to apply. So this is the simplest possible way to run Puppet code. Most of the time we'll be using the Puppet agent command, which gives us more flexibility and it lets us build a whole catalog. But in this case, we're just running this one command. What Puppet will do is it will look in that manifest, it will identify all the things that are in there, which in this case is just one thing. It will then check to see if that package is installed. Since it's not already installed, it goes ahead and it installs it, and you see that finishes in just about 4 seconds. Now if I run this again, keeping in mind that we're expressing desired state, we're not telling Puppet to run a script, you notice that this time, because the package is already installed, Puppet is going to do nothing. If I remove that package and run Puppet again, of course it will reinstall it to get the system back to the desired state. So that's the idea with Puppet. That's the organization of our directories. We have a manifests directory, and that's where Puppet starts when it applies the configuration to a system. Within that, we can have as many files as we want, written in the Puppet language using the .pp extension, and each one of those has configuration that will be applied to our systems.